In this video, I would like to show you a couple of examples of reading and writing a binary file. This is our next presentation, and our next example is on slide number 20. 2 ways to write a binary string. In this section, we will explore the functionality of the data output stream, buffered output stream, and the file output stream. In the next part, when reading binary strings, we will see the functionality of the data input stream, the buffered input stream, and file input stream, which both belong to input stream and output stream hierarchy in Java I/O library designed to process binary data. I also opened slide number 21, a counterpart for reading a binary file, so we can have both of these examples side by side. As in our previous examples, when I am looking at file processing Java code, my first question is this a plain text, binary, or random access mode of operation? And the answer in this case is that, of course, this is a binary file processing, but we continue writing the information sequentially, so it is intended to also read this information sequentially in the same order. Of course, reading and writing must be coordinated because both programs must follow the same exact format to process the data correctly. So why do we need this example? Well, it's going to demonstrate us how you can read and write Unicode characters in Java. So here, first, to write the information, we create a data output stream object named out, which is a class that supports writing all primitive Java data types to an output stream in a portable way. An application can then use a data input stream to read the data back. This data output stream implements the data output interface, as we've seen on our class diagram, which declares methods like write integer, write double, write float, so you can write any primitive data type with this class. So our data output stream object is constructed as a combination of buffered output stream and file output stream, and the buffered output stream is a class implementing a buffered output stream to write bytes to the encapsulated output stream, like this file stream, using memory buffer, which of course gives you a good performance without too many calls to the operating system to physically write every single byte that must be written into an output device. And the file output stream is a class for writing data to a file, and file may already exist or may be created automatically. The purpose of this class is to support writing of raw byte streams, basically binary data, something that is not intended as a readable text. And in our example, we have a couple of methods that show the possibilities of writing data strings into a file. One method is write UTF, and the second method is write chars, or write characters. Recall that strings are strings of characters, which in Java are 2 bytes in size and store Unicode characters. Therefore, a special attention has to be given on how to write the content of the string into a binary file. So the first method, write UTF, which means write Unicode characters, takes a string as a parameter, and what it does, it first writes the length of the string into a file, followed by UTF-8 encoding of every character present in the string. By the way, UTF-8 means that normal Latin characters, like English alphabet, will be written as single bytes, not Unicode characters, which require 2 bytes in Java memory. So just a single byte. I will show you how to look at the result of this write in our next video. Once write UTF completes the work, you can find out how many bytes altogether were written into a file by calling the data output stream size method. The second method to write a string is write characters, also taking your string as a parameter. And this method writes every character to the file, which is 2 bytes per character. If the string is empty, then no characters will be written. Basically, for each character, 2 bytes are written into a file. Therefore, when you read the characters back from the file, you must know how many characters you need to read back. It becomes your responsibility, and most programs will also write an integer value representing the length of the string and then call write characters to write the characters themselves. Right after calling write chars, we can calculate how many bytes were written the second time by getting the current buffer size and deducting the number of bytes that were already written prior to this into the buffer. I would like to do a quick test of this code in my next video.